Calcium imaging is a technique which is rarely taught to undergraduates because the equipment is just way too expensive.
Future of neuroscience is doing imaging research on neurons. And one of the key stumbling blocks is the price of fluorescence microscopes, tens of thousands of dollars usually. And even at a school like Cornell, there's no lab courses for students that incorporate the kind of imaging that we're doing with our scope. I think the ultimate innovation of our project is that we're able to bring calcium imaging of neurons into the undergraduate laboratory classroom.
And then along with that, I think changing the culture of the class, which has always had a mixture of engineers and biologists, but they don't often talk to each other and work together. They tend to segregate in groups in the class. But I think the curriculum we're designing will kind of force students to look at all aspects of what's going on, not just the biology, but like you say, the optics and the physics and the engineering skills and putting things together and testing the instrumentation. We've been very fortunate at Cornell to be able to have the resources to buy high quality instrumentation for the students to use in the classroom. But maybe that's left out a little bit of their deeper understanding of how the instrumentation works and to move to that next step with the students too. We've long had an interest in do-it-yourself kind of neuroscience instrumentation to try to spread that to other faculty at other institutions too, and either all over the world.
And we each have kind of a different background and different expertise. And I'm kind of a more molecular genetic neuroscience person. Bruce is more of a neurophysiology type person, and Jim is a DIY neuroscientist, really great at building things. And so kind of the three of us together could really brainstorm and come up with ideas and try them out and revise our design and until we got things working.
When we first started out, we were thinking about primarily using Raspberry Pi devices as little computers with the Raspberry Pi cameras. And we were hoping to use that as our camera system and develop that into an epifluorescence microscope to keep costs down. I think pretty early on, we realized that the Raspberry Pi camera just didn't have the optics that we needed to be able to capture the images at the speeds that we needed. Switching gears early on really improved the design, but I also think it made the scope and the research a lot more feasible.
At each step, we had some hurdles and weren't exactly sure how we're going to solve them, but we all worked together, and Jim would come up with another version of the scope. And all of a sudden, one day, we had it, and we saw this pattern of neurons that were lighting up, and just like in a paper we'd read, and we were like, wow, this is amazing, we did it.
Any number of techniques that we could use with this microscope, including regular epifluorescence of, not just calcium imaged embryos, but all kinds of fluorescent probes and neuron tracing and so forth. So I think I'm hopeful that students and faculty who use this scope will really run with it and bring a whole host of different types of curricular innovation to the project.
There must be a lot of people, a lot of young scientists without equipment to do very simple things just because the equipment is so expensive. And so there are a lot of minds out there that we could hopefully give new instrumentation for to create the science that we'd like to see everywhere.
We can really change how undergraduate neuroscience is taught across the country if we can do this successfully.